Hello students, till now you have learned how to solve quadratic inequality by sign change method, and you also know the conditions for real solutions and no solutions, and in the real solution there can be two solutions or one solutions. So you know the conditions, right? I just quickly revise it. So if a function fx is given, which is ax in the form of ax square plus bx plus c, the discriminant delta is b square minus 4ac. For real solutions, for real solutions or real roots, discriminant should be greater than equal to 0. For real and distinct solutions, the discriminant should be greater than 0. It means two different solutions, then discriminant is greater than 0. For real and equal solution, equal solution, or you can say one solution. For one solution, the discriminant delta should be discriminant delta is equal to 0, right? And for no solution, for no solution, discriminant is less than 0. So no solutions means the curve will either lie above x-axis or below x-axis, right? For one solution, you know that it should intersect the x-axis only at one point like this, and for distinct solution, it will be like somewhat like this, right? Or like this, it will intersect at 2 points. So till now you know these things, right? And you also know how to solve quadratic inequality with the help of sign change method. That's what we have learned in the last class. Now we are going to learn how to implement in numerical questions whatever we have learned till now. So let's solve a question. See, the question is, find the values of m for which the quadratic x square plus mx plus 2 equals to 0 has one real solution, two real solution and no solution. That's the question. So what we'll do, first we'll find out the discriminant, because discriminant will determine how many solutions possible, right? So we'll find out the discriminant first. So discriminant is b square minus 4ac, right? So in this case a is 1, b is m, and c is 2. So we'll find out the b square minus 4ac. B is m square minus 4 multiply 1 multiply 2. So which will give you m square minus 8. That's the discriminant. Now part A, one real solution. So for one real solution, discriminant has to be equals to 0, right? That's what we learned. So it means m square minus 8 equals to 0. That will give you m square equals to 8, which will give you m is equal to plus minus of root 8, which is plus minus of 2 root 2, right? That's the value, two values of m we got. For these are the two values of m for which there will be one real solution. Now see, the question here is, you don't have, see, in this question you don't have to find the values of x. You need to find the value of m so that x will have only one value. That's what it means. Okay. Part B, two real solutions. So for two real solutions, we'll do here part B, two real solutions. This discriminant should be greater than 0, right? It means m square minus 8 greater than 0, right? And we found that it m when and we found in part A that there are two values of m plus minus 2 root 2. So m value is plus minus 2 root 2, right? M is equal to plus minus 2 root 2. We can write it like that when it is equal to 0. M square minus 8 equals to 0. So first we will put it minus 2 root 2 and 2 root 2 on the number line. Then we will apply the sign change method. So we'll start from right, plus, minus and plus. As it says greater than 0, so the answer is m less than minus 2 root 2 or m greater than 2 root 2. Okay, that's the answer. It's very simple. Now part C is no real solution. No real solution happens when delta is less than 0. So it means m square minus 8 less than 0. Again, we already have found out the value of m, that is plus minus 2 root 2, and the sign diagram we have drawn here. For m square minus 8, we will less than 0, we will take the negative interval. So it means m value should lies between minus 2 root 2 to 2 root 2. That's the answer. Is that clear? Okay, so this is the answer for part A, plus minus 2 root 2. For part B, m less than minus 2 root 2 or m greater than 2 root 2, because delta is greater than 0. Here delta is less than 0, so we'll get the answer m lies between minus 2 root 2 to 2 root 2. Now the next question. Find k if the equation x square minus k plus 3x plus k plus 6 is equal to 0 has one root. So one root means one solution, right? And for one solution, discriminant is equal to 0. So we'll first find out the discriminant, and for that let's write down the ABC. So A is 1, B is minus of k plus 3, and C is k plus 6. Now discriminant delta is b square minus 4ac. B is minus of k plus 3 b square minus 4 into 1 into C is k plus 6. Okay, so here we will get k plus 3 square minus 4 k plus 6. That's the discriminant, right? We can simplify it further. So we'll get k square plus 6k plus 9 minus 4k minus 24. So you will get k square, 6k minus 4k is plus 2k, and minus 24 plus 9. Minus 24 plus 9 will give you minus 15. Okay, now we need to simplify this. So if you factorize it, you will get the factors like minus 15. There will be two factors like 5 and minus 3. So that factor addition will give you plus 2. So the factors will be k plus 5 and k minus 3. Okay, so these are the two factors what we got. Now it says one root. So part A, for one root means one solution, discriminant is equal to 0. So you will get k plus 5, k minus 3 equals to 0. So from here you will get k is equal to minus 5. So there will be two answers for part A, minus 5 and 3. Now part B, two real roots. Two real roots. So two real roots, it means discriminant should be greater than 0. It means discriminant we know k plus 5 and k minus 3 greater than 0. So as it is a quadratic inequality, we'll do it by sign change method. So there will be minus 5 and 3, as the coefficient of k square is positive. So we'll start from right side and we'll write plus, minus and plus, and as it is greater than 0 we'll take the negative. As it is greater than 0, So we'll take the positive, as it is greater than 0, we'll take the positive interval. So k less than minus 5 or k greater than 3. Positive interval and positive interval. This is your answer and this is your answer. Now part C, it says no real root. Part C, no real root. So no real root means delta is less than 0, right? K plus 5, k minus 3 less than 0. And we have already drawn the sign diagram here. And for less than 0, k has to be between minus 5 and 3. So that's the answer. That's the value of k. Okay? It's very simple. Now we are going to learn intersection of a line and a curve. And a curve. And here the curve will be quadratic curve. That's parabolic curve. Okay? So how a line and a quadratic curve can intersect? So a quadratic curve is parabolic and a straight line. So they can intersect like this. Two points of intersection. They can intersect like this. So it's like a tangent to the curve. Here it is one point of intersection. And this is like, and it can be like this, like 0 point of intersection or no intersection. So isn't it like discriminant, like two solutions, one solution and no solutions? So what we will do in these kind of questions, when a quadratic curve and a line is intersecting, that is given to you. First step we'll do, equate both y's, equate both y y's and form a quadratic in x. Quadratic equation in x. And write in standard form. And write the equation in standard form. Standard form means this one, ax square plus bx plus c form equals to 0. So equate both the y, like y of the line and y of the quadratic function, and make a and form a quadratic in x and write that in standard form. And after that you can find out discriminant, and if it is intersecting at 2 points, so here in this case discriminant will be, discriminant delta will be greater than 0. Here if it is 1 point of intersection, so discriminant equals to 0, and no intersection means discriminant will be less than 0. So you must equate the y's, form a quadratic in x, and then write in the standard form, find out the discriminant, and that discriminant, if the line is intersecting the curve at 2 points, so you must write, if the line is intersecting the curve at 2 points, in that case discriminant will be greater than 0. If it is intersecting on only 1 point, then discriminant is equal to 0, and if it is not intersecting, the discriminant will be less than 0. Okay, let's solve a question. Find the distance between the point of intersection of the line and the parabola. So you need to find out the intersection point. So equate both the y's. X square minus 4x plus 6 equals to 2x plus 1. Write in the standard form. So x square minus 4x minus 2x plus 6 minus 1 equals to 0. So x square minus 6x plus 5 equals to 0. Now here you don't have to find out the discriminant. Here you just need to find out the intersection point. It means you need to find out the values of x and y. So just solve it and get the value of x. So if you factorize it, you will get two factors, minus 5 and minus 1. So x minus 5, x minus 1 equals to 0. So you'll get 2 points, 1 and 5. Now if you got x as 1, so for x as 1, you substitute here, you will get the corresponding y. So 2 into 1 plus 1, which is 3. So 1 comma 3. And for x is equal to 5, y will be 2 into 5 plus 1. 10 plus 1 is 11. The point will be 5 comma 11. Now what it asks, it's asking the distance between point of intersection. So it is intersecting at these 2 points and you need to find the distance between. We will apply the distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square. So x2 is 5 minus 1 whole square plus 11 minus 3 whole square, which is 4 square plus 8 square, which will give you 16 plus 64, which is root 80, right? Root 80 units. You can leave it like this, or you can simplify it further, right? Or you can write in 3 significant figure, but root 80 is also fine. Next question is find the value of a so that this line has exactly one intersection point with the parabola with the equation this. So here you need to find out this a so that this line is intersecting at only one point, right? It's like a tangent to this curve. So this is the situation. This is the situation. This line is a tangent to the curve. Only to say it means if the line is intersecting only at one point, it means the line is a tangent to the curve, and in this case discriminant has to be equal to 0, right? So first step, equate both the y's and form a quadratic in x. So 2x plus a, that will give you x squared plus 3x minus 2x plus 2 minus a equals to 0. So x squared plus x plus 2 minus a equals to 0. So now we'll find out the discriminant, and as it is intersecting only at one point, discriminant is equal to 0. So discriminant delta, we will write b square minus 4ac. Okay, so b is 1 square minus 4 into 1 into c is 2 minus a. So we'll get 1 minus 8 plus 4a. So 4a minus 7, that's the value of a we got. And for one real solution, discriminant is equal to 0. It means 4a minus 7 equals to 0. A is equal to 7 over 4. Okay, the next question is for what value of k, y is equal to kx and y is equal to kx square plus 3x plus k have no solution. So this is the line and this is a quadratic curve. No solution, it means it doesn't intersect the curve, and for that we will equate both the y's, will form a quadratic, and we will find out the discriminant and discriminant less than 0. Okay, that's what we are going to do. So y is equal to kx, so equate both the y's, kx square, equate both the y's, kx square plus 3x plus k is equal to kx, which will give you kx square plus 3x minus kx plus k equals to 0. So kx square plus 3 minus kx plus k equals to 0. Now from here we'll find out the discriminant. Now from here, now from here we'll find out the discriminant. So A is k here, B is 3 minus k, and C is k. We are comparing with the general quadratic equation. So discriminant is b square minus 4ac. So b is 3 minus k whole square minus 4 into k multiply k. So we will get, if you simplify this, you will get 9 minus 6k plus k square minus 4k square, which will give you 9 minus 6k minus 3k square. Now it says no solutions, it means discriminant is less than 0, right? So 9 minus 6k minus 3k square, 9 minus 6k minus 3k square less than 0. So if we multiply with negative, so we'll get 3k square plus 6k minus 9 greater than 0. Which will give you k square plus 2k minus 3 greater than 0 if you divide by 3 both side. Now if you factorize it, you will get k plus 3 and k minus 1, right, greater than 0. Now as we got two factors, so this factor will give minus 3 and this factor will give you 1. So sign change method, plus minus plus, as we are looking for greater than 0. So k less than minus 3 or k greater than 1. That's the answer. It's very easy. We had started with so first step we did here, we equated both the y's, we form a quadratic, and in the standard form we found out the delta and delta less than 0, and then if you multiply delta become this 3k square plus 6k minus 9 becomes greater than 0, and we got the answer. Now there is a quadratic in different forms. These kind of questions also come in exam. So where x4 minus 5x square plus 4 equals to 0. So as it is a power of 4, you can form a quadratic in other variable. So let x square is equal to t. So x4 will become t square, right? So it will become t square minus 5t plus 4 equals to 0. And from here, if you factorize it, you will get t minus 4 and t minus 1 equals to 0. That will give you t equals to 1 and 4. That means x square is equal to 1 and x square is equal to 4. So when x square is equal to 1, x will be plus minus 1, and x square is equal to 4, that means x is equal to plus minus 2. These four solutions are there. Plus 1, minus 1, plus 2, minus 2. Now another question. 6x plus root x minus 1 equals to 0. So in this case, if we assume let root x is equal to t, so x will become t square. So you'll get 6t square plus t minus 1 equals to 0. And so 6 into minus 1 is minus 6. We'll factorize minus 6 as 3 and minus 2. So we'll get 6t square plus 3t minus 2t minus 1 equals to 0. 3t common, which will give you 2t plus 1, minus 1 common, 2t plus 1 equals to 0. 2t plus 1 and 3t minus 1 equals to 0. So 2t plus 1 equals to 0 or 3t minus 1 equals to 0. So from here you will get t is equal to minus 1 over 2, and from here you will get t is equal to 1 over 3. T is minus 1 over 2, that means root x is minus 1 over 2. Right. Square root of x is equal to minus 1 over 2, and from here we get square root of x equals to 1 over 3. So as square root of x is equal to minus 1 over 2, so we can write as x root square root of x plus 1 over 2 is equal to 0. For no values of x, this equation will be equal to 0. So this will give you, this is not possible. So no value of x here. So root x is equal to 1 over 3. So in this case we'll square both sides and we'll get x is equal to 1 over 3 square, which is 1 over 9. Okay. So x is equal to 1 over 9 is the only answer. That's how you need to solve the quadratics. Thanks for watching the lesson.